brought to you today is a nice short lecture, so you can start spring break early. Vectors are puck and a cakewalk. So what are we in? Math 54, this is 8.3, and it is on the introduction of vectors. Now, if you're going to take physics, vectors are very important. If you're going to go down the entire or any engineering, Calc 3 is almost primarily vectors. So this will come back. I promise you, but it's not hard. It's not hard. So when we have things like mass, 50 kilograms, or speed, 50 miles per hour. These are both quantities. We can even call them magnitudes. It's an awkward word to use here. But if we have something, we also have stuff. In life with both a quantity and a direction. Velocity is speed with direction. .75 miles per hour, north by northeast. I will get to Sacramento in a couple hours. Or LA if I go in the opposite direction. We represent vectors. We represent variable vectors, I should say. And sometimes just name them with letters, even though they're not variable. Sometimes just labels. With an arrow over it. That is how I tend to write my arrow over a vector. It is the same thing as doing this, but that the fucking bottom half of the arrow oftentimes fucks up, it overlaps what you're writing and looks like shit. This looks cleaner and it represents it pretty well. So this is the vector B. I can have the vector W doing the same thing. Let's say B is in this direction. And let's say W is right next to it. Like that. So B is parallel to W. And that's often done as shown as two vertical lines between the two letters. Put another one here, let's put down U as well, let's put a U on here. A U vector. And that's also parallel to U. Now. Vectors of equal length. The length is called the magnitude. Vectors of equal length. And pointing in the same direction. Are equal. B equals W here. They don't have to start at the same point. Vectors in general. Unless the starting point is given, the vector can move about. Because it's just a length or magnitude and a direction. Which is gonna be pretty handy in a second. Equal length and opposite direction. We get a negative sign. B equals negative U. They're the same length but pointed in opposite directions. That's a lot to write down, so let me pause. Textbooks often use boldface for vectors. It's annoying as fuck. It's more noticeable with, typed stuff when it's bold. To write, do like a handwritten bold, it's fucking lame. I don't know why they just don't do the arrow, it probably uses less ink. We're not using typewriters anymore, they're fucking printing shit with fucking printers. They still fucking use boldface stuff. I'm trying to write this all down, cause there's a lot there. Gotta get through all the terminology bullshit. Before we start doing some math. Good stuff. We'll have a few more terminology things, but they'll pop up as we're using them. No, I probably got another half page of terminology. Exciting shit. Does anyone need this up still longer? I see people. Lewis, if you're still writing, you can still write. You good? Was that be good? So another way to write vectors, if we know. where the vector starts. Called the initial point. Where it ends. The terminal point. And if the points are labeled. We can write our vectors like this. Say P and Q. This is another way of writing this vector is PQ. So if there's two letters for a vector. The first one is the initial point. And the second one is the terminal point. And usually these don't move. Unless they're arbitrary points. Alright, I'm gonna call this also, I'm gonna call this vector B for here. We'll call it B. And then I'm gonna have. An opposite vector. This will be negative B. When we add vectors. We. Go from. It's often said as tip to tail. So I'll redraw B and I'll redraw negative B, that's B. That's negative B. And if I wanna do tip to tail, what it means is this is the tip. If I say B plus negative B. I'm gonna take negative B and I'm gonna move it so that. The tail of negative B. Tail of negative B. Is right where the tip of B is. And so B will point back right along that to here. What happens when you add two numbers that are equal and opposite?
They cancel each other out.
And what do you get?
0.
A zero. You get the same thing here, but it's called the zero vector. Just a point. I'm not a big fan of zero vector because there's no magnitude or there's no length. So how can you have a direction? But you kind of need zero when you're doing vector addition and stuff like that, there's gotta be something that's a zero. And it just doesn't, the vector doesn't go away, so. Just adding stuff later on to it, as those. So. The sum of two vectors is a vector. It has to stay a vector, that's why we have the zero vectors. And the vector addition is commutative. Anyone remember what that word means in mathematics? They swap, they commute, they move. Vector A plus B is the same thing as vector B plus vector A. Garrett was privileged enough to see how my evening class goes. And he pointed out afterwards that you guys are much better towards me than the evening class. Well, heckle me, you guys are good students. Or at least respectful. Good job.
It's your class right after this.
It's right after this, yeah. One of them, she's gotta be 17, her name's Krista. She's a high school student and. She answers a lot, she's like very, very bright, she answers a lot of questions. But at one point, she said something that was a little funny, so I wrote something sassy on the paper with her name on it. And after that, she's heckled me every single day. Which is not a problem, I think it's fucking hilarious. I think if I'm throwing it, I can take it too. But she doesn't mind dishing it either, it's fucking hilarious. The other ones, a couple of guys kept telling me, you should get your hair tapered. So it looks good, I'm like, fuck you. Fuck you guys. Well, tell me that's what you're saying, I know what you're trying to say, is it'll look better, or. Like, I like my hair, it's like, if I gel it, it's gonna look great. Usually I just brush it, and so it might not look the best, but it's not like tapering is not gonna fix the top.
A ruthless, dude. Ruthless.
Yeah. Alright, that gave you everyone look, no. Ooh, that's still right, a couple of them are still right, I'll wait. We got time. We're literally going over 4 problems in this spot today. And we're almost to the point where we're doing it. And y'all better have done this fucking homework by next Tuesday. Not next week, spring break, don't come to school. But the following Tuesday, cause it's going to assume you know how vectors work. Fair enough,
Sounds like a plan.
sounds like a plan. Alright, everyone looks like they're good, nope. They're already You good? Alright, so speaking of vector addition, let me write down an example of two vectors being added together. If I'm doing A plus B. Let's say A is like that. And B is like this. Yeah,
So it's, this may be coming up later, but. Is there like a rule for positives and negatives, like what direction is generally positive, or generally negative, or is that just based on the starting point of the direction?
generally vectors are all positive because they're representing a length. The only time we use a negative is when we're comparing it to another vector. Does that make sense?
So it's just the, whatever, the reference direction is the one you're starting. with.
Right. So if I do A plus B, what I'm doing is adding the tail of B to the tip of A. So this is like a shadow of B. And that's gonna put A plus B right there. So it's got. We're adding the tip or the tail, and then since we can do B plus A. I can move the tail of A to the tip of B. That's like a shadow of A. It's still A, I'm just like, I don't wanna confuse everybody, if I put A and B in the first spot, A and B can move. But I'm still gonna get the same thing, B plus A is gonna get me this same arrow. So this is doing the B plus A route, and this is doing the A plus B route. It is so much easier to figure out where a vector is going to end if you draw it tip to tail. If you try to start with two vectors like this and go, where does it go? It's kind of hard to like place. But as soon as I like move the vector over a little bit, like make a copy of it, all of a sudden it's easy to see that this is U and this is V. It's easier to see as soon as I move a copy of U over where U plus V is. Otherwise, I could have ended, if I didn't draw this V or this U over here. It's kind of hard to tell which direction it's going, you know what I mean? It's very beneficial to draw that extra arrow, even if you only do it lightly. So this makes a parallelogram. Parallelogram. Rectangles and boxes are both parallelograms, but not all parallelograms are rectangles or boxes. Parallelograms have opposite sides, have opposite lengths. Or equal lengths. Opposite angles are equal. Let me redraw this parallelogram right here. If this is angle A. And that's angle B, or that's gonna be angle A also, since they're opposite. That's what I mean by opposite. Adjacent angles are supplementary. You wanna remember what that word means?
180.
They add to 180. So if I call the other two angles in here B. Angle A and angle B equal 180. Parallelograms have 4 sides. Miss that part. Called quadrilateral. Quad is 4 and lateral is side. What the RI is, I just guess connects it, I don't know, I'm not Latin. I don't speak Latin, I bet my buddy does. I bet he knows a lot of fucking language, he learned fucking how to read and write hieroglyphics. What the fuck? Like just as a hobby. He likes languages. Sick man, very sick man. Okay, so diagonals. Bisect each other. Which means cut in half. So the red line and the green line are cutting each other in half. But. Usually don't. Bisect the angles. Like as you can see here, if I look at like, if I call this theta. Or phi, and this is theta right here. Ah, shit, I do different. Let's go with theta. Set theta on both ones and root p both times. They're not equal. Phi doesn't equal theta there. They're not the same size. Boxes do it, diamonds will do it, but everything else, no, the angles won't be perfect split. Two more vocabulary terms. Coming from up here. Vector A and vector B, when we add them together. Let's call this vector C. C is the resultant vector. And this is often used with forces. A physics thing. And it's called the resultant force. And we might as well put our last vocabulary term on here and then start doing the problems. Our last vocabulary term is the equilibriant. The equilibriant is the opposite of the resultant vector. So as I wrote C up there, here it would be negative C. But it looks like we're done writing. Yep, almost. Good, David?
Yeah.
Sure.
I had the negative C.
So let's find the magnitude of the resultant. So two forces are acting on a point. I can give you an example you can easily relate to. Chandeliers, you know how they hang from the ceiling? Chandeliers used to, they hang from the ceiling. This is my chandelier. Let's put little candles on. And they used to be held up with a rope. Rope holding it up. The force is working on this point right here. Where the, not really a pulley, but the hook. Or loop. It's got a force going downward. Usually called G for gravity.
Is the rope on the ceiling?
Yeah,
Cause it looked like it was going down, that's why.
well, it could be along the ceiling,
Oh,
in this case, it's not along the ceiling.
Oh.
I see what you're saying, so I'll draw a ceiling in there. Doesn't have to be. And someone could be like hoisting up. Like pulling, the old days, like before we had electricity, that shit was all candles, it had to be lowered down, candles all lit, hoisted back up. So someone pulling on the rope has a force going this way, let's call it F. I'll use a lower F, why not? Someone's pulling on the rope, and so there's a force on that point right there. There's two forces acting on that little hook that's holding the rope, one's pulling it down, one's pulling it the other way. So. Redrawing it without the picture, we got like this and like this. And so our resultant vector is gonna be like something like that. So let's put some numbers and shit into it. As we're doing it, let's say the. Force of. 32 newtons and 48 newtons. Act on the point. And the angle between the forces, or angle between them. Is 76 degrees. Find the magnitude of the resultant force. Those look about 76 degrees apart. That'll actually work. I just drawn two things. For your reference, a Newton. Often goes by the letter N. Is about 0.225 pounds. of force. Newton is the most commonly used thing for forces in engineering and physics. Because we're one of the only countries that like to use feet and shit like that. Everyone else is on the international system and Newton's is the thing. Americans use can use foot pounds, the units in foot. In American it's called foot pounds, and it sounds fucking stupid, as stupid as right? It's a stupid fucking name, foot pounds. So Newton is actually named after Isaac Newton, inventor of calculus, a whole bunch of shit, smart guy. Alright, so if I label this picture up here, the shorter one's probably the 32 newtons. This one is the 48 newtons, the longer one. And it looks like our angle between them is gonna be 76 degrees. So let's flesh it out and make a quadrilateral here. And we're looking for this diagonal length here. If this angle is 76 degrees, this angle is 76 degrees. What is that angle? How'd you get that?
Minus one.
180 minus 76 is 104. So that is 104 degrees. And the ghost line on this ghostly thing down here is a 48. So if I strip off half that quadrilateral. I have 32, 48. And 104 degrees right here, and I wanna find that. We have two sides and the angle between, oh, what, why? Yeah, we're going back to the Federal law of cosines here. Law of cosine says, and since I use question mark, I'm gonna keep question mark. Question mark squared equals 32 squared. Plus 48 squared. Minus 2 times 32 times 48. Times cosine of 104. Law of cosines. Still trig class.
So we were doing distance the other day, but. We could just use values in general.
This is it is a distance, it's a length,
Oh,
the way I drew it, yes,
I was thinking because the newtons, that's not a distance, that's like a.
no, but it has a direction and a magnitude, like. The road thing, I could. Write a length that has a 42, but like gravity, there's no like. All we know is it's pointing downwards, but it has a strength pointing downwards. Like. The further you are from the planet, the weaker gravity is. Gravity, as we know it, is what it is on the surface of the earth. But like you get up high enough. There's no gravity, not effectively. So yeah. So magnitude. So along with David's question, magnitude just isn't just a distance. It can represent strength of a force. Strength is probably the wrong word, but I think. Hopefully everyone has some idea of what the fuck I mean.
Physics, we're doing physics.
Here we do, yes. It was a physics problem. Soon as I had the word Newton in there, this became a physics problem. A lot of the examples in vectors are physics related. Alright, let's see what this shit is. 38 squared plus 48 squared. Minus 2 times 32 times 48 times. Oh, I hope I'm in degrees, yes I am, cosine of 104. So I've got question mark squared. Is approximately 4071.184. When I take the square root. It's approximately 63.8. Newtons. Does that look reasonable with the picture? Does the question mark side look longer than the other two sides?
Yeah.
Yeah. So that's our resultant force. And our equilibrium would be the other direction. We'll do another, the next problem has an equilibrium. Equilibrium is the other direction, the same length. This becomes, you end up having you can have a lot of forces acting on a point. On an object. Gravity is usually acting on the object, but if it's struck by something, there's a force from the impact. And so you kind of like, which direction will it go? Or which direction does it start going initially?
So a lot of physics uses trig, right? Uses trig as a base to explain things, right?
I'm not gonna say a lot of physics, but a portion of physics. What? Quite a lot, actually. We go beyond vectors, we do something called vector fields later on, oh, you do in Calc 3 and in physics. A vector field is like the magnetic field. And you've seen it where like, I know you, hopefully you've been to a museum as a child where they have the iron filings. And they put the magnet and it makes these little concentric rings going out, that's the magnetic field. It's literally vectors going in a circle pointing back towards itself. And electricity has an electric field. So there's things in physics that have it, it's good shit. Alright, next problem. Or you guys want a 10-minute break real quick? Does anyone need to go to the bathroom?
No, just keep going.
We're like, fuck it, I wanna get out of here as soon as possible. Shut your pie hole, Jones, and go. Alright, so we've got forces. In this example, 54 newtons. And 42 newtons. Acting on point A. With an angle between of 98 degrees. Our goal is to find the angle. Between the equilibrium. And the 42 Newton force. You've got it written down, we'll draw a picture. Two going that way. We'll have the 54 going down this way, it's a little bit longer. Which means our resultant force. That will be our resultant force, I'll call that B. And this is negative B. Our equilibrium. And we know this angle here is 98. We want to find theta. Okay, so what can we do?
We know that the side opposite of 54 is also 54.
I like that, let's put that in.
Chop off the top triangle, and then when you find the inside angle, just take 180 minus that inside angle, and we'll find the.
So we can do this, we know this is 42, this is 54. This would be V. And what did you wanna go with?
I was just thinking, oh. Yeah,
Find that angle.
yeah, we know the other angle on top, because 180 minus 98 will give you the other one.
Okay, so what is this angle?
Like 82,
82.
yeah, 82 degrees.
Okay, now what? Find magnitude of V. Cause we want negative, we're gonna use negative V, so maybe having the length of V would help,
Yeah,
does that sound reasonable? So let's find a. They often show length like this. For V. V squared is. 42 squared. Plus 54 squared. Minus 2 times 42. Shit, this is going on, I wrote it too close. Times 54 times cosine of 82, you guys said?
Yeah.
Alright. Cosine of 82. And if I take the square root of that. I'm getting about. Length of B is about 63.6 newtons. Now what?
You need to find that inside bottom left angle is, I'm assuming.
Sound reasonable? So what is theta, or we'll
Yeah.
go with phi here? Cause if we get phi, then our angle theta. Theta will be 180 minus phi. How can I find phi with what we have? We now have, let's put the triangle with what we got. 42, 54. About 63.6, and we're gonna go with phi here.
You could do. Sine.
And we know this is 82.
I don't know if sine or like cosine, that's the direction I'm thinking, is like taking one of the trig functions of that angle and then doing the inverse trig function to find what theta is.
Isn't there
Is that
like
far off?
a side?
We do it,
Okay.
we add, but we have a name for it, we've done it this chapter. Law of sines. So we've got an angle with the side and we've got an angle with the side. Right, we could say sine of phi over 54 equals sine of 82 over the 63.6. So sine of phi is 54 over the 63.6, sine of 82 degrees. Now, if you don't clear your calculator, you'll have a more exact answer. Don't like type in 63.6, use your result from doing this calculation. Like, I've got a bunch of decimal places here. So if I use that, I'm gonna do 54 divided by that. And then I'm gonna multiply it by sine of 82. And that's sine of phi. So I'll do sine inverse of that. And I'm getting about 57.2 degrees. So phi ends up being about 57.2 degrees. So what's theta?
See. 122.8.
And we did some rounding there, so I'm gonna say approximately. Well done, Patrick. Fucking means it addressed what we need to do the whole way. That is not fucking intuitive. Right?
I was definitely wrong, yeah. Thank you, Patrick.
Cool. Promising, hopefully, you know.
There's hope for you yet.
Yeah.
That's an odd way of saying it. You're figuring it out without being told what to do, like, he might have said the law of sines of the logger, but he said to take the inverse of. The inverse of the angle, to find the angle, and that's what we did. Effectively, you take the inverse sine here. I think that's what you were going with.
Yeah, no, I just didn't say Austin, it's.
So that fucking 8.1 and 8.2 came both into this problem, right? Law of cosines up here, law of sines here. Why did we bother doing 8.1 and 8.2? Because you use it in physics and engineering and all that shit. I say physics, but most of our uses for physics are structural engineering. Building buildings and bridges and shit like that, and the forces on a bridge, and you need to know how all that shit works. Alright, next problem. You wanna need this up under? Okay. There is a 2,500 pound car. Parked on a hill. With a 12-degree incline. Find the force on the parking brake. What?
San Francisco.
Well, I don't know, well, San Francisco's got some secret fucking hills in that.
That's what it's.
12 is actually not that much.
Well,
I'm sure there's areas in fucking Tulare, or maybe not, I don't know, Tulare's pretty flat.
Like by
But Celsius-
Celia on the way up to Lemon Cove and stuff.
Oh, yeah,
for
there's
sure.
areas that have 12 degrees isn't that much.
There's some in San Francisco that are like fucking 70,
Yeah.
something's ridiculous,
Same.
It's terrible, dude.
There's some shitty fucking inclines and. Like you're like, nope, gotta rotate the tires so that it fucking hits the curb, cause. The parking brake will eventually fucking fail. Alright, so let's draw a picture. I'm gonna say that's about 12 degrees right there. We got our car. Make it. A fucking shitty looking car. Which direction is the 2,500 pounds acting? Acting straight down. So what this is actually doing, there's actually. and you'll learn about this in physics. There's the force that wants to make it go downhill. And there's the force perpendicular to the surface that it's on. So that 2,500 is like a resultant of. What's going downhill. And what's going like into the ground. Part of the weight is pressing on the ground, but part of the weight wants to pull it downhill, but not all of it wants to pull it down. It's like, it's not 2,500 pounds of force downhill. We're wanting to find the parking brake. What's the parking brake doing?
Holding the
stopping it
weight
from-
of the car.
Going last.
The parking brake counters this one, right?
Yeah.
It's gotta be the opposite of that one. Parking brake is countering. The downhill force. I'm gonna. Do this. This would make a right angle right there if I did that, because gravity's pointing straight downward. So what is this angle right here?
70,
78. Now. This vector here and the ground are also perpendicular. So what does it make this angle?
I mean. We're talking about that bottom inside angle.
This angle right here,
Oh,
look at that,
90.
it's the 12 again. 78 plus 12 is gonna give us a 9, cause if this is 90, then this is 90,
no. Okay.
right? Okay, I'm gonna redraw that 12 right now. Now that I've got 12 degrees going like that. And I know this is 2,500 pounds going downward. Rather than using this line right here, I'm gonna make a line right here that does this. Where this is the same as the incline. Same as incline. So it's like doing that. So the way the force, this vector, or this is the downward force. This is actually. That arrow. I just. It's drawn weird, but it's not, it doesn't look like it has the same length, but it is the same, it's pointing in the same direction. Let's assume I drew the same length. It's the same vector,
That would be the resultant, and then the red.
and this
one-
is like, the 2,500 is the result. We got a vector going this way and a vector going this way. Result, this is a resultant of those two vectors. The force pressing it against the ground and the force. That wants to pull it downhill. I've got 12 degrees there, I've got 2,500 here. This is F. And we want negative F. Cause it's pointed in the opposite direction, but it's gonna have the same length. So if this is F. This is negative F, and that's my parking brake. That make sense? Can I find F? With the 12 degrees and the 2,500 pound.
You have 92, right? So you can.
Yeah, this is a 90 degree.
For 90 and 78, could you use law of sine? You have an angle? No.
Well, one of those, we could, but like. We've got it, it's gonna end up being, yeah, let's use law of sine. You're gonna feel silly after I do, but it does work. Law of sine says, alright, so we're gonna do, we want F, we're gonna do F over sine 12. Equals our 2,500 pounds. Over sine of 90. What's sine of 90? 1. So F is gonna equal sine of 12. Actually, you're probably not gonna feel silly because you're probably not gonna recognize it here. I could have said this was F over 2,600 pounds. Equals sine of 12. Just by like multiplying by the 12 and dividing by the 2,500. But you know this as opposite over hypotenuse. So we didn't really need to go with law of sines, but if that's what you thought of, that's what you thought of when we run with it. So SOHCAHTOA would have worked here. But we can find F. 2,500 times sine of 12. 519.8 pounds of force. Foot pounds of force, I don't know. I think it's foot pounds. No, pounds is really it's a force. Because pounds very much require, it's gravity. So we have a mass times acceleration, it is a force. Pounds is a force. But pounds is something else, it's another
It's a
physics
pressure
unit.
one?
I think it's pressure. I think it might be pressure.
Yeah.
Well, PSI is pounds per square inch. That would be foot squared times pounds, so like, it's in that physics area. I'm not a physics teacher, get a load of that. Don't remember that one. But if it's 519.8 going downhill, it's 519.8 going uphill. So most of the weight of the car is like going into the ground. But still, 519 pounds of force. That's gonna roll if there's no parking brake on. Alright, ready for more? One more? The hardest part of that problem is you may want to use this triangle right here. Because you've got a flat line there and it looks like it makes a nice right angle. But this line here is not that line there. So the hardest part is remember to make that right there, do this part right here. And you're making it parallel to this right here. It fucks me up every time, I fucking fuck my triangle up every time, I get stuck and I gotta stop thinking about it. Alright. Similar. 18 pounds of force, we'll go with 18.0 pounds of force, because we're fancy. Is required. To hold a 74-pound crate. It's no longer on wheels. Ah, fuck it, we're gonna say wagon. Cause I don't wanna write off friction force does matter. And friction force on tires does have an effect, but it's a lot less on something that rolls, very minimal on something that rolls. A force of 18 pounds is required to hold a 74-pound wagon. On a ramp. What is the incline of the ramp? Founded with fucking dirt and shit. Well, I don't know why we'd have a wagon on a fucking incline and not want it to move. A year. That's why they had a crate. We could have done a car again, but like. So the 18 pounds is which direction?
Up.
Up, excellent. Okay. Which way is 74 pounds?
The resultant, right?
Yeah. Gravity is straight down. Let's make it proportional to what it is. 74 is a lot bigger than 18. What?
Are you running gravity right now, or are you running?
This is gravity.
Okay.
So that's not the resultant though.
Well, it's a resultant of, sorry, it's the resultant of. Use green. The force into the earth perpendicular and the force pulling it downhill. It's a resultant of those two. Good question. So like that last one, we're gonna make a line here that matches our incline slope. Looking for this angle right here. Now, we saw in the last problem. That's the same as this angle right here. That's the G direction, our theta is there, that's the perpendicular direction. So this is like, this angle right here is 90 minus theta. And since it makes a right angle, that's theta. And this arrow here is that arrow there. So if I reorient it where it's just straight up and down like this, that's my theta, that's 18 pounds. That's 74 pounds. And this is making a right angle. I think one of the hardest set of, like the on a hill thing is one of the hardest things in beginning physics. Cause these fucking triangles are like, which way do I line up the triangle? And it's having this bottom part of this triangle parallel to the ground. And parallel to our course. So I rotated it, obviously, I rotated a little bit so that it looked a little cleaner. Can I find that there?
Yeah.
Are we gonna go with lob signs again, or are you like a
Just do
psychopath?
sine. No, just do sine of the theta. Opposite over.
Sine of theta is opposite over adjacent. So theta equals sine inverse of 18 over 74.
0.245708126, bunch of numbers, you probably wanna.
That sounds like it's in
So, yeah.
radians. I'm not
It
believing you.
is, look at that, it is. Let's do it again,
Why don't we say it's approximately 14.1 degrees?
that's what I got when I put it in degrees. So, I believe it,
I'm like, there's no way it's a fucking less than a tenth of a degree, or less than a quarter of a degree. That's the clear giveaway, when you do something and your degree ends up being less than one. Fucking immediately check if it's radians. Cause having a degree of less than one. Is almost imperceptible to the eye. Now, I'm gonna go with imperceptible. What's wrong, David?
I mean, it makes sense for the most part, but I'm like. If it's on a ramp. Gravity always pulls to the center of the earth.
Yeah,
regardless of
it
that.
grabbed, it like. But it's on a hill, so the ground isn't flat.
So it's like some of that 74 pounds isn't trying to get to the earth anymore, it's trying to go down the side of the ramp. I don't know if that's a good question or not.
Yes,
Versus if it was on a
Yes.
flat surface.
that is an excellent way to see it. In fact. We know that 18 pounds of it is going down,
Okay,
okay? So that's doing 18 pounds that way. We've got 74 pounds going this way. We could actually figure out the force between it and the earth. Cause things that are against each other are forces that are equal and opposite. The car is pressing on the ground, so the ground is pressing on the earth. There is a force there. That's perpendicular to the earth. The surface. Even though it's on an incline, it's perpendicular to it. So we could figure out this. The 74 pounds is a sum of these two. But it's not exactly, it's not 74 equals 18 plus so and so, it's. Since they're at an angle, if there's more to it than that. But we could figure out pretty easily what it is. How do I find that?
Pythagorean.
Pythagorean. 18 squared plus question mark squared is gonna equal 74 squared. So we can find out how much of the 74 is the 18 pounds going downhill. And how much of it's actually the force pressing it against the ground. That make sense?
Yeah, this is all brand new.
Right, this is like something we haven't really done a lot of physics in here. When you go down the highway, they have those weigh stations for trucks. They are always on flat ground, so the weight is pressing straight down. And gravity is in the direction of the weight or the pressure on the earth. But if they were stupid enough to put a weight scale on an incline, it would be measuring this rather than the actual force here.
Okay, that's what I was thinking, like it's like lighter in a way.
Yeah, this is not gonna be 74 because. This is the hypotenuse, so 74 is the longest side of the triangle. So this is going to be less than 74. And we can figure out what it is right there real quick. That's what we got for today. On after spring break, we're starting something called the dot product. Which is like multiplying vectors. We've done addition and effectively subtraction of vectors is adding the opposite. So we start multiplication on not next weekend, yeah. I'll be in the Mesa Center this weekend, and I think the weekend after, if you wanna come in and do fucking weight problems. A weight on an incline,
Yeah, physics seems
Oh,
fun.
yeah, I saw somebody sold it, they were
it's
like.
fucking really interesting.
Yeah, I think the application for the real world is what makes it fun.
Yeah.
For doing like,
Yeah.
yeah, exactly,
Cause math's is fucking boring, it's just like, why are we doing this?
yeah.
Right now, we're building out, like, we can do some problems with algebra and trigonometry,
And it's on.
but a lot of the things we do in real life, like, well, like engineering, with the bridge shit, the trig comes into play. But it's more, you're doing the force of the physics with it too. So it's where they're using other stuff.
That's a little smarter for today.
Oh, yeah.
Yeah, so I was like, that's like.
Learn some shit. Have a good weekend, have a good break.
So like, yeah, so I was like, what?
Switch closer to what?
That's like, that's.
Build my own house.
Oh, yeah.
Baby steps, I'll get there, I'll have all the knowledge.
You're less than 1 degree closer.
Yeah, exactly, yeah.
I have a quick question.
Yeah,
Do you know when you would be uploading the notes? For this, for the pre-com?
I'll get them uploaded tomorrow. I don't think I loaded Tuesdays. I'll get this week's stuff loaded tomorrow.
Okay,
It's my anniversary today, or I go home and do it
Oh, really?
tonight, yeah.
thanks. And you'll be at the Medicine Center on Saturday?
Yeah,
Okay.